Hello, I want to just stop and welcome y'all to Unit 3. We're going to be learning all about polygons, and we'll be learning about the properties of those polygons. The objectives in Lesson 3.01 are to identify properties of polygons, classify polygons by their angles and by their sides, and to classify triangles by their sides. Here are some of the key words that we're going to be going over: center of a polygon, central angle, equiangular polygon, equilateral polygon, equilateral triangle, isosceles triangle, a polygon, a regular polygon, scalene, side, and vertex of a polygon. Alright, so let's start off with our polygons. Here's the word polygon, and it can be broken up into poly, which means many, and gon, which means angles or sides. I love Greek words, and I love breaking them down. Actually, it's Latin, but anyway. When we put them together, we get polygon, a many-sided figure, or a many-angled figure. Now here's the definition of a polygon. It is a closed figure in a plane formed by 3 or more line segments, such that each line segment intersects exactly 2 other line segments at their endpoints only. So here's some examples of polygons. Here's some non-examples. A circle is not a polygon because it doesn't have any angles or sides. This intersects right here, okay, so that makes it not a polygon. And this polygon, these two ends aren't meeting with anybody. They're just out there flapping in the wind. So the line segments form the sides of a polygon, and the point where the sides intersect is the vertex. We've learned all about vertexes. Now a polygon with angles, with all the angles congruent, is called equiangular. So this would be like a rectangle, because a rectangle has 4 90-degree angles, and they're all congruent, obviously, because they're all 90 degrees. And a polygon with all sides congruent is called an equilateral polygon. Okay, all the sides are congruent. Notice the angles are not congruent, just the sides. And that's a rhombus. A regular polygon is both equiangular and equilateral. So that would be like this triangle right here. And we usually call it an equilateral triangle. Okay? And another example would be a square or a regular pentagon, and so on. Okay, regular polygons. Oh, well, I guess we better define regular. Regular polygons have special properties. The center is the point inside the polygon that is equidistant from each vertex. Okay, so here's your center, and it's equal distance. No matter which vertex you choose, this segment from the center to the vertex is going to be the same length. An angle formed by line segments drawn from the center to 2 consecutive vertices is called the central angle. So, and they're pointing it out to you right here, that this is the central angle. And notice this word consecutive. It's kind of like adjacent, means they're right next to each other, one right after the other. Like the numbers 1, 2, 3, and 4, those are consecutive. Okay, the measure of each central angle of a regular polygon is 360 divided by the number of sides. So for a regular polygon where m is the measure of the central angle and n is the number of sides, this is what your formula is going to look like. But you don't really need a formula because you can just count the sides and 360 divided by the sides. So this is a hexagon which has 6 sides, so 360 divided by 6 is going to give you 60. 60 degrees is what that central angle measure is. Okay, now for classifying triangles. Y'all bet y'all remember this from elementary and junior high. Scalene triangle, a triangle with no congruent sides. See, all these sides have a different measure. And since all the sides have a different measure, all the angles will also have a different measure. Okay, so nothing's the same in a scalene. Equilateral, all your sides have the same measure, all the angles have the same measure. But since we're calling it equilateral, all we're worried about is the sides. And then an isosceles has at least two congruent sides. At least. Okay, so here's the two congruent sides. If you flip back here and you look at a equilateral, it's also an isosceles because it has at least two sides that are congruent. Okay, let's look at some examples. It says tell whether each figure is a polygon. For all figures that are not polygons, explain your answers. So here we have an oval, and in one of our first slides we said, hey, it doesn't have any angles, so how can it be a polygon? Because a polygon has many angles. So we're going to say no, because it does not have three or more sides, but many sides is also what polygon means, but you understand what I'm saying. No angles, no sides. Oops, I'm just flipping through those like a happy cat. Okay, there we go. And this right here isn't going to be a polygon because of this intersection that's going on right here. Now I'll give you the answer. No, because two of its sides intersect in a point other than an endpoint. So see, here's the endpoints. This is not an endpoint. It's an intersection. And then you've got this one down here, and it's not going to be a polygon because, like I said, remember in that one drawing I said those ends were flapping in the wind. Well, these ends right here are flapping in the wind. The official answer says because one set of sides doesn't intersect. Makes it an open figure. Okay. So it says answer each question, use complete sentences, blah blah blah. Okay, in a polygon, what is the name of any point at which two line segments intersect? I'll give you like 2 more seconds. Vertex. Don't forget about the vertex. That's what you call it. What features are common to all polygons? You could put several different answers down for this. Like features that are common to all polygons, their sides meet at the vertex, you know, things like that. So here's some sample answers. All polygons are closed figures and they are formed by 3 or more line segments that intersect at their endpoints only. And a polygon has the same number of sides, angles, and vertices. And that's a good thing to remember. That helps you whenever you're working problems. Alright, in this example it says answer each question. Use complete sentences to describe your reasoning. Give 2 conditions for a polygon to be a regular polygon. A regular polygon must be equilateral and equiangular. The equilateral means it has to have equal sides. They all have to have the same measure. Equiangular means all the angles have to be congruent. Now in this example it says classify the polygon by the number of sides it has and then determine whether it is regular and describe your reasoning. Well, this first one is a rhombus. Remember, well, we will be talking about how a rhombus has all congruent sides, but they don't want you to classify it that one. They just want you to classify it by the number of sides. So this would be a quadrilateral, and it says determine whether it's regular and describe your reasoning. Well, it looks like it can't be regular because the angles are different sizes. And that's what the key said, because not all the angles are congruent. Okay, on this one right here, we know it's a parallelogram, but remember we're just classifying it by its sides, how many sides it has. It only has 4 sides, so that means it's going to be a quadrilateral. And remember, to be regular, all the angles have to be congruent, all the sides have to be congruent. And this one isn't meeting either one of that criteria. This next one, we know it as a square, but remember we're classifying by the number of sides, so that means it's just a little old quadrilateral. And remember, the criteria for being regular has to have all angles congruent, all sides congruent. So it is a quadrilateral and it is regular because everybody's has the same size. And on this last one, if you look, you count the sides, it's got 5 sides. The polygon with 5 sides is called a pentagon. And look, all the angles are congruent and all the sides are congruent. So that means it is a regular polygon. Okay, I think this is the last example. It says for each type of polygon, determine if it's possible to create a polygon that is not regular but equal angular. And here's what they created right here for a pentagon. And I did not measure these angles, but I'm going to assume that they're equal angular because that's what the key said to, that's what the problem said to draw, and this is what they put in the key. Then B says not regular but equilateral. So all the sides have the same length, but the angles are different. Alright. So what we learned in this lesson is a polygon is a closed figure in a plane formed by 3 or more line segments, such that each line segment intersects exactly 2 other line segments at their endpoints only. The line segments form the sides of the polygon. Any point where the line segments intersect is a vertex. And the center of a regular polygon is the point inside the polygon that is equidistant from each vertex. An angle formed by the line segments drawn from the center to 2 consecutive vertices is called the central angle. The measure of each central angle of a regular polygon is 360 degrees divided by the number of sides. As usual, you need to be reading through the LMS lesson, looking through the reference guide at the same lessons. I don't think you're doing 1 through 29 odd, but yeah, maybe you are. I'm not sure. That doesn't sound right. So be sure to look in the LMS and make sure what problems you got to do in the problem set. And please, when you get finished working on those problem sets, contact me or attend TOGA before you work on the 3.01 quiz, because I definitely want you to make good grades on your quizzes, since there is no corrections or retakes on those. Alright, well, that's the end of this lesson, and thank you for listening.